Hello, my name's Peter DiMarzo. I'm the National Vice President of the Backflow Prevention Association of Australia. And in conjunction with Watts, we will show you the testing procedure of a double check valve. We will be working on the 007 model. The testing procedure for a DCV, backflow prevention device, is outlined in Australian Standards AS/NZ 2845.3 2020. This standard comes into operation on the 1st of May 2023. Whether you use a digital or a mechanical test kit, the procedure remains the same. Today we've chosen to use a mechanical test kit. Sometimes this type of test kit is referred to as an analogue test kit. To understand the testing procedure, let's look firstly at the typical test kit. The test kit itself is made up of 5 major parts. You have the differential pressure gauge. The test kit valves are known as test kit valves A, B and C. And you have 3 hoses, the high pressure hose, the low pressure hose and the vent hose. Next we will look at the DCV assembly itself. The assembly of the DCV is made up of the upstream isolation valve, a Y strainer, the DC prevention device itself and the downstream isolation valve. On this assembly, in line with Australian Standards 3500.1 section 4.6.1 part J, provision must also be made for the replacement of the backflow prevention device. So we would include unions on smaller devices and bolted flanges on larger devices. Looking at the assembly itself, we have 3 test taps. They're known as test tap number 1, number 2 and number 3. The upstream isolation valve is known as number 4. The downstream isolation valve is known as number 5. And of course we have the Y strainer. Now that we understand this information, we can begin our testing of the DCV. After notifying the property owners, check that the upstream isolation valve is turned on and the downstream isolation valve is turned off. Open and close the test taps 1, 2 and 3. This removes any rust or debris out of the system. Next, check that test valve A is open, test valve B is closed and test valve C is closed. We now want to test the upstream and downstream isolation valves. Connect the high pressure hose to test tap number 3 and open. Open the test valve B and C and flush water through the vent house. This eliminates any air from the test kit. Next, close test kit valve B and C. Now close the isolation valve. You'll notice a high reading on the gauge. Slowly open B and drop the gauge and then observe. Looking at the differential gauge, we've got to see if the needle rises or falls. Should the needle be rising, this will indicate that either the upstream or the downstream isolation valves are leaking. To determine which one it could be, simply open test tap number 1. If there is water coming out, a continuous discharge of water, then it is the upstream isolation valve that is leaking. If the gauge is dropping, this will indicate that the downstream isolation valve is leaking. Of course, if the needle remains static and does not move either way, then we know that both the upstream and the downstream valves are not leaking. If the downstream isolation valve is leaking, then the leaking isolation valve shall be repaired or replaced. If the upstream isolation valve is leaking, then the leaking isolation valve should be repaired or replaced. We now move on to the next step. This is the cleaning of the Y strainer. Pull it out and we check the Y strainer, make sure there's no debris in it. This one is clean, that's good, so we can put it back before we proceed with the testing. To test the DCV, we need to close test tap number 3, Remove the hose. We open the upstream isolation valve, ensuring now that the test kit valves A and B are closed and C is open. Connect the high pressure hose to test tap number 1 and the low pressure hose to test tap number 2. Open test taps 1 and 2. Open test valve A and bleed water through the vent hose. Close test tap A. Now open test tap B and vent water through the vent hose. Slowly close test kit valve B and record the reading on the gauge. It must be above 7 kBA. If it is not, then the first check has failed and must be repaired or replaced. We'll now test the number 2 check valve. Close test taps 1 and 2 and move your hoses. Low pressure hose to test tap number 3, the high pressure hose to test tap number 2. Open test taps 2 and 3. And open test tap A, bleed water through the vent hose. Close test tap A. Open test tap B and bleed water through the vent hose. Slowly close test kit valve B and record the reading from the differential pressure gauge. This too must be above 7 kPa. If it is not, then the second check valve has failed. It must be repaired or replaced. In each of the above steps, if repairs are necessary, the testing shall be repeated. Close test taps 2 and 3. Open the downstream isolation valve and this restores the system to the operating condition. If you've not done so, record all of your readings and complete your paperwork.